Hi everyone, this is Dr. KG Shanti, Professor, ACE, R.M.K College of Engineering and Technology. In this video presentation, we are going to study about systems and its classification. And we will be seeing part 1 of the classification of systems. Now let us see what is meant by a system. Right, a system is one which accepts one or more input signals, does some operation on it to produce an output. Right, now look at the diagram. See here, an input signal or excitation is given to the system, and what we get is the output signal or response. Now what does the system do? The system do one or more operations on the input signal so as to accomplish a function. Right, now look at the diagram for a system. What I can tell, a system is nothing but an entity that responds to an input or a signal that and generates an output. Now an example of systems, let us see. First one is a normal any circuit. Now we give the input to the circuit. See here, we give the input to the circuit. Here you have a resistance connected in capacitor, that is in parallel with the capacitance, which performs some specific operation, and we get the output. Now let us see a few more examples of systems. A camera. A camera is a best example or well-known example for a system, right? You have the input light falling on the camera. That is, the camera captures the pictures, does processing, and you get the image. Right? The other one is going to be another example is going to be a speech recognition system. Right? Now input is nothing but your speech. You match it with the signals, that is with the speeches in the database, and you identify it. Right? So that is going to be called as speech recognition system. Now still more good example is going to be an automobile system. See here, right? Now when you look at your automobile, you give pressure on the accelerator, which is going to act as the input signal. So depending on the pressure what you give on the pedal of the accelerator pedal, based on that the speed of your automobile is going to vary. So this is once again one good example of your system, right? So a normal bike, right, even that is nothing but an automobile. That is an example for a system. Now music system is also one another example for a complete system where you play in your CD and you hear the music. Right, now let us now look into the classification of systems. Right, continuous and discrete time system, linear and non-linear system, static and dynamic system, time invariant and time variant system, causal and non-causal system, stable and unstable system, invertible and inverse system. Now in this slide we are going to define, or I'm going to tell you the difference between continuous time and discrete time system. Right. Now a continuous time system is one which acts on continuous time signals. You all know what is meant by continuous time signal. A signal that is defined for each and every instant of time is called as a continuous time signal. Right. Now see here, your input is defined as x of t. The output what you get is going to be y of t, and the system does some operation on the input signal x of t so as to produce a y of t. Right? T denotes the transformation. So how do you represent response y of t? Y of t is nothing but the transformation that is applied on the input signal x of t. Right, now let us look into discrete time system. What is a discrete time signal system? A discrete time system is going to be one which operates on discrete time signal, and you all know what is meant by a discrete time signal. A signal that is only defined for discrete intervals of time. So you represent a discrete time signal as x of n, and the output here is represented as y of n, and once again t denotes the transformation. So what do you get? Y of n is nothing but transformation applied on x of n. Now let's look into the next classification called as static and dynamic system. Right. Now what is meant by static or dynamic system? A static system is one, or what I am going to call it as a memoryless system, where the output of the system is due to the present input alone. And output at any instant of time depends only on the present inputs. Say, look at the example, y of t is equal to 2 into x of t. Right, now let us substitute time instances, say y of 0. Say at time t is equal to 0, you have y of 0. Y of 0 is nothing but 2 into x of 0, which means that the output at time instant 0 depends only on the input at time instant 0. In the same way, t is equal to 1, t is equal to minus 1. Look at it, all the three cases. The output at any instant of time depends only on the input at that instant of time. Right, now look at one another example in dt, discrete time. Discrete time, you all know, you represent it as y of n. So y of n is nothing but x square of n plus x of n. Now see here, substitute y t is equal to 0, or here I'm sorry, you have to substitute n is equal to 0. Right, same, n is equal to 1, n is equal to minus 1. Once again see here, y of 0, the output at instant y of 0 depends upon only x of zeros. Y of minus 1 depends upon x of minus 1, and that is at that instant, that is input at that instant alone. So that is why this system is going to be called as static or memoryless, because the output at any instant of time depends only on the present inputs. And the best example for a static system is nothing but a resistor. Right? Resistor itself is a memoryless system where the input x of t, with the input x of t taken as the current and with the voltage taken as the output. Yes or not? So V is equal to IR. Right. Now let us proceed on with what is called as dynamic system. Right. Let us look into an example. Now see here, y of t is nothing but 2x of t plus x of minus t. Let us substitute the value t is equal to 0. Right? T is equal to 1. T is equal to minus 1. Right? Now see here, at t is equal to 0, y of 0 is nothing but 2x of 0 plus x of minus 0. Right? You are calculating the value for a y of 0, but it depends upon x of minus 0. Here y of 1 you are calculating, but it depends upon x of minus 1. Y of minus 1, it depends upon x of 1. Right? Here x of minus 1 is past input. Yes or not? Y of 1 you are calculating, but it depends upon the value of x of minus 1, which is nothing but your past input. Right? Now in the next case, look here. When you look into x of 1, what is x of 1? You are calculating y of minus 1, but it depends upon x of 1, which is nothing but your future input. So what is the conclusion you arrive at? The output at any instant of time, if it depends upon past or future values of the inputs, then it is going to be called as a dynamic system, and hence the name dynamic system or system with memory. Is that clear? Right. Now let us see one more example also. Y of n is equal to x square of n plus x of 2n. Right, in the same way substitute the values. For n is equal to 0, n is equal to 1. See here, for n is equal to 1, y of 1 depends upon x of 2. X of 2 is a future input. Right. Now n is equal to minus 1. Here n is equal to minus 1 depends upon x of minus 2, which is nothing but a past input. Correct. So which means that if the output at any instant of time depends upon past and future values, then such a system is going to be called as dynamic system. A best example of a dynamic system is going to be a capacitor. And you all know what is the equation for a capacitor? 1 by C x of tau into d tau. Y of t is equal to 1 by C integral of x of tau into d tau, or V is equal to 1 by C integral of I dt. Right. Now, let us look into one example of static and dynamic system. Right. Given a question, y of t is equal to x2 of t plus 2x of t. The same way you have to find out, right? Find out for t is equal to 0, t is equal to 1, t is equal to minus 1, right? When you look into it, t is equal to 0 depends upon only present inputs. But when t is equal to minus 1, we see that it depends upon that is y of minus 1 depends upon x of minus 2, which is past, right? Y of 1 depends upon what? X of 2, which is future. Hence, what system is this? Since it depends upon past and future, the given system is going to be a dynamic system. Right. Now, one more example, let us see. Y of n is equal to sine x of n. Y of 0 is equal to sine x of 0. Y of 1 minus 1 sine x of minus 1. Y of 1 is equal to sine x of 1. So see here, the output at any instant of time depends only on the present inputs. So what is the system? The system is going to be called as a static system. Thank you, students.